This real Unreal Engine 5.5 observer evaluates the same target in 3 situations. Inside the 45-degree half angle, DotProduct 0.848 exceeds the 0.707 threshold, so the target is detected. Outside the angle, DotProduct 0.287 fails immediately. In the third position, distance and angle both pass, but a wall blocks the visibility trace, so the result is occluded. In this lesson, we will build the distance gate, convert a field of view angle into a dot threshold, compare normalized directions, add line-of-sight verification, separate rejection reasons, and prove all 3 states with automation, runtime logs, and genuine Unreal frames. Begin with the vector from observer eye to target. Its length is the target distance. This detector accepts candidates at 900 Unreal units or less. Anything farther returns out of range before more expensive work. Distance is a broad phase gate. It should match gameplay intent, not only visual scale. An AI may use different ranges for hearing, peripheral awareness, combat lock, and firing. Squared distance can avoid a square root when only a range comparison is needed, but this lesson keeps the readable distance value for logs and presentation. Normalize the observer's forward vector and the direction to the target, then calculate their dot product. A dot of 1 means the target is directly ahead. 0 means 90 degrees to the side. Negative values place it behind the observer. The inside target produces 0.848. The outside target produces 0.287. Dot product avoids calculating an inverse cosine every frame. Once the angle limit is converted into a cosine threshold, detection becomes one inexpensive comparison. The configured half angle is 45 degrees. Cosine of 45 degrees is approximately 0.7071. The observer calculates that threshold once in begin play. A target passes the field of view gate when dot is greater than or equal to the threshold. Use half angle consistently. A 45-degree half angle creates a 90-degree total cone. Mixing full angle and half angle doubles or halves the intended view. Clamp designer inputs to a sensible range and recalculate cached thresholds when runtime configuration changes. When geometry passes, the observer traces from its eye component to the target using the visibility channel. The query ignores the observer itself. If the first blocking hit belongs to the target, line of sight is clear. If another actor blocks first, the result becomes occluded. In the third frame, distance is 613 and dot is 0.913, so both broad gates pass. The pink wall intercepts the trace before the target. Collision responses therefore belong to the detection contract. A decorative object that unexpectedly blocks visibility can change AI behavior. The detector returns explicit states: detected, outside angle, out of range, occluded, or searching. The target and observer change color from green to red to amber. The world space label reports result, distance, dot, and limit. A single Boolean loses useful information. Named reasons support different reactions. An outside target can remain ignored. An occluded target can trigger last known position behavior, and an out-of-range target can be removed from consideration. Explicit states also make regression failures much easier to diagnose. These are genuine game mode frames rendered by the included Unreal project. The first shows the green target inside the cyan field of view guide and reports detected. The second shows the red target beyond the guide angle and reports outside angle. The third shows the amber target geometrically inside the cone, but hidden behind the wall, so it reports occluded. The observer, target, wall, colored pads, 48 guide points, shadows, distance, dot product, threshold, and state labels all come from the same running Unreal scene. They are not generated substitutes. The Unreal automation test passed with 1 success and 0 warnings or failures. It verifies default range and half angle, forward and inside targets, angle rejection, range rejection, same location handling, the 45-degree cosine threshold, and result labels. The runtime then proves the detected dot of 0.848, outside dot of 0.287, final occluded dot of 0.913, all 3 native captures, 48 guide points, and valid true. Pure tests catch vector mistakes. Runtime evidence catches target lookup, component locations, collision channels, wall placement, line traces, colors, camera, and rendering. The reusable pattern has 4 steps. Reject candidates beyond the detection distance. Compare forward dot direction against a cached cosine threshold. Trace only the candidates that pass geometry. Return an explicit detection or rejection reason. Cache target references or query candidates through a dedicated perception system instead of searching the world every tick. Add teams, height limits, peripheral vision, memory, update frequency, and server authority as separate policies. For guards, turrets, cameras, creatures, sensors, and stealth games, this is an AI-friendly C++ foundation with visible, testable Unreal behavior.